In chapter 1 of this CCNA 3, we talked about single area OSPF theoretically. Today, just a minute, please. So today we want to go to configuration. But before we do the configuration, we need to take care of some theoretical stuff again. Then we'll go to the lab. So just to give you a background of what we are trying to do, let me just give you another background. What we are trying to do. You remember we are dealing with wide area network. When I say wide area network, two or more LANs separated by the wide geographical location. So this is a router somewhere here, connected to a switch. And then there are computers. Maybe this is London. And then there's another router somewhere, maybe in New York, connected to a LAN there. I have explained it in the last class when we did our explanation. So we want a situation whereby people on this LAN in London can talk to the people on the LAN here in New York. We've been able to do that with our static routes. We learn how to use static route to make remote connections happen. And when I say remote connection, I don't mean remote connection as in VPN, because that's another ball game. And I remember sending you guys recordings that will help you to learn what happens here or what will be here. And that is where you learn about one technology, and then you also learn about IPsec VPN. So those two videos are very important for what you see in the cloud. Now, we did this with static routes, which is manually done. But what we want to do now is dynamic. We want a situation whereby this is dynamically done. So that's why we've been talking about dynamic routing protocols. And the only one we have been considering is OSPF. So in today's class, we are going to go into OSPF configuration. We're going to have two or more LANs connected together through wide area geographical location. And then we're going to see how we can use OSPF to link them up together. So let's proceed. What are the things we want to talk about today under this configuration? Ali, can you hear me draw the link for the class in the WhatsApp? Somebody is trying to connect and she's having a problem.
I'll do that.
Okay, thank you. Thank you. Thanks. So we have a lot to do today. Don't forget, OSPF is a core topic. We can't rush it. We can't skip it. You have to know it, and you need to know it well. So in today's class, where we're trying to do the configuration, there are a few things we are going to learn about before we go to the first configuration. We want to talk about OSPF Router ID. But after that, then we're going to go into configuration. We're going to talk about point-to-point OSPF network. We're going to talk about multi-access OSPF network, how to modify single area OSPF, default route propagation, and verify single area OSPF. Now, I am not sure if we can do all. I am going to take my time. We can't do all today. We'll finish it on Wednesday because we need to understand something. Now, OSPF is big. So many things to talk about. We've talked about a lot of things. Can you imagine a topic being given 2 chapters, chapter 1 and chapter 2? And even this chapter 2, if care is not taken, we can't finish it in this class. So that should be maybe on Wednesday. So the first thing to talk about is OSPF Router ID. When you hear OSPF Router ID, what are we talking about? Huh? Something is missing in my PowerPoint. Okay. Okay, see it here. I've seen it. So you can see a topology here where we have 3 routers connected together. And don't forget something I told you. In between 2 routers is a network. In between 2 routers is a network. Like in this scenario, now look at the network address between these 2 routers. In between these 2 routers also is a network. Look at the network address here. And in between these 2 routers is a network. Look at the network address here. And of course, there's something probably I don't think I've mentioned that in this class. You may not know that. We are supposed to have a switch here and then have computers connected. And then have a switch here and then have computers connected. And then have a switch here and then have computers connected. But sometimes when we are labbing, that is when we are doing lab now, for us, the people that have advanced in this thing, we use a loopback interface to simulate a local area network, and it will work as if there is a computer on that segment plugged to a switch. Loopback interface is a logical interface. We are going to talk about that today. You can activate it on a router and give it an IP address as if it's a regular computer. So anytime you see a topology like this, they just didn't want to drop a switch and connect computers and give computers IP addresses. So they just go to the loopback interface of the router and give it an IP address. You choose a network address, you give an IP address. You choose a network address, just like you choose for your LAN, you give an IP address. You choose a network address, you give an IP address. So this address here is simulating computer on a local area network. Now, if you take a look at this topology very well, you will see that router 1 is directly connected to 3 networks. This one, and this one. So router 1 wouldn't know about this network. He wouldn't know about this network. He wouldn't know about this network. He does not even know how to go to the internet. Similar scenario with router 2. With router 3 connected to this network, directly connected to this network, directly connected to this network. But router 3 does not know about this network. He does not know about this network. He does not know about this network. Router 3 doesn't even know how to go to the internet. Now, if you take a look at router 2 is directly connected to this network. People here on this LAN here can go to the internet because they are directly connected to the router that is connected to the internet. Router 2 is directly connected to this LAN, to this one link. Also the same here. But router 2 doesn't know about this network. It doesn't know about this network. It doesn't know about this network. And as long as the routers on your network do not have the same information, there is going to be reachability problem. So we can achieve this with static route. That's what we did when we did routing concepts, static route and stuff. But what we want to do today, we want to configure OSPF. And if you see something here, this interface, they put it in area 0. This interface in area 0. This interface 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 area 0. Why did they put all these interfaces in area 0? because we are doing single area OSPF. And guess what? The interface that connects to the internet is not inside that area. You can see the boundary they put. You can see the boundary. They cut it from here. All these interfaces are in area 0. And that is exactly what we're going to do. But what about the interface that connects to our internet connection? That one is not going to be put in area, in OSPF. It's going to be outside. Yes, I've started the recording, Mr. Oladayo. Thank you. I started the recording. So what I'm driving out here now, I have said this before. Anytime you see a topology, you must be able to analyze that topology. Because if you don't understand the topology, how will you do the configuration? Anytime you see a topology, you must be able to analyze that topology. Just like what I just did for you right now. Anytime you see a topology, you must be able to analyze that topology. So let's continue. So there's a problem here, and we're going to solve that problem maybe on Wednesday if we can't get it today. It is only the LAN that is connected to router 2 that can browse the internet. How will this LAN here browse the internet? How will this local area network here browse the internet? We're going to solve that problem maybe on Wednesday. I don't think we can get there today because we have a lot to do. These slides I'm going through is almost 62 or so. Router configuration mode for OSPF. How do we configure OSPF? OSPF version 2 is enabled using router OSPF, take note, process ID. Router OSPF process ID at your global configuration mode. Please mute yourself. Mr. Already, help me out. Who is that? Oh, Ali, help me out. Who is that? Eniola, can you mute yourself? Thank you. So, take note. When we want to activate OSPF, this is the command. We say router OSPF, then we put process ID. And we do this at global configuration mode. What is this process ID all about? And I'm going to explain all of this. The process ID value represents a number between 1 and 65,535. And it is selected by the network administrator. You decide the process ID you want to use on your router when you are configuring OSPF. And look at this. The process ID value is locally significant, meaning we just use it on a router. You can use another one on another router. You can use another one on another router, even though the best practice is to use the same process ID on all your router. It is considered best practice to use the same process ID on all the router, OSPF router. So that process ID is just a number that represents a process ID is just a value rather that represents a number between 1 and 65,535. And what does it really do? It's just to identify the routing process under OSPF. And that is the way OSPF behaves. Look at that as the example here. They are at global configuration mode A. If you want to configure OSPF, the command to configure OSPF is router OSPF. Router OSPF. The next thing here is process ID. And it is a number between 1 and 65,535. So this administrator has decided to pick 10. You can pick 100, you can pick 200, you can pick 1,000. It doesn't really matter. Router OSPF. Then the process ID. Without the process ID, you cannot configure OSPF. And this is done at global configuration mode. And when we hit enter, you're going to see all kinds of options that you can get, things that you can configure. We're going to come to all of this later. But let's talk about process ID. That's one concept here. Process ID is one thing. Another thing we need to talk about is router ID. And take note, there are two different things. Process ID goes with the command router, OSPF, then you put the process ID. You can say 1, you can say 2, you can say 3. Don't forget that. But there is another one. This one here now is called process ID. There's another terminology here you need to be aware of also. It is called route ID. Router ID is different from process ID in the sense that router ID identifies the router under OSPF, but the process ID identifies the routing process. They are two different things. It's like you have a router with 3 different IP addresses. Under OSPF want to pick just one of the IP addresses as its ID that will represent that router. So when we see any message coming from that router, we know the identity of that router that sends the message. An OSPF router ID is a 32-bit value represented like, I prefer that way, like an IP voice default address. It is used to uniquely identify an OSPF router. And all OSPF packets includes the router ID of the originating router. So if a router is sending packets, its ID is always in that packet. Every router requires a router ID to participate in an OSPF domain. Take note of that. So you don't have ID, router ID, you cannot participate in OSPF. You can't participate in the election, you can't do anything. It can be defined by the administrator. Take note of that. This router ID now, the administrator can decide it or automatically assigned by the router. It can be defined by an administrator or automatically assigned by the router. We're going to see. What we're going to see first, we will allow the router to automatically assign. Then we're going to overwrite it or override it by putting our own. So what does the router do with this router ID, or what does OSPF do with this router ID? The router ID is used by an OSPF enabled router to do the following. Number 1, participate in the synchronization of OSPF databases. We've talked about this in the last class. They use their router ID to participate. To participate in the election of the designated router, and I also spoke about this. They use their router ID to do all of this participation. It's like, here I come with my identity or with my ID, router ID. That's what they use it for. For people that probably missed that OSPF class, you probably need to go and listen to the video. We talked about synchronization of database. We talked about a lot of things in that class. Only theory. We talk about GR, we talk about BGR, we talk about multi-access network and all of that, even point to point. So now let's find out, how does a router get its ID? Are there precedence, order of precedence? Yes. So let's find out. Router ID, order of precedence. Cisco routers derive the router ID based on one of 3 criteria in the following provincial order. So for your router to have ID, it's going to be in this order. Number 1, when the router ID is explicitly configured, that's by the administrator right now, using the OSPF router ID command. Take notes. If we use this command, that takes precedence. We are going to do this manually. But if we don't use this command on the router, how will the router pick its ID? Number 2, the router chooses the highest IPv4 addresses of any of configured loopback interfaces. This is what I'm saying. If you have a router right now and there are loopback interfaces are logical interfaces. Loopback, let's say loopback 0, loopback 1, loopback 2. The highest IP address. Loopback interfaces are not physical interfaces. They are logical interfaces on a physical interface. Just like logical interfaces, the way we have logical interfaces on our sub interfaces when we did VLAN. And I'm going to show you one example. So if you have loopback interfaces, it will choose the highest IP address as the router ID. What if we did not do this and we do not have loopback interfaces? This is how the router will choose its ID. The router chooses the highest active IPv4 address of any of its physical interfaces. So if you have these interfaces like this, maybe this side is 192.168.100.1 on this interface. The other interface is 192.168.101.1. If you compare these two IP addresses, you see that this IP address is higher than this IP address A. So it will pick this IP address as its router ID. Two factors. Take notes. So let's go to lab. Let's go and lab some things. Let's lab. In doing our lab, let me tell you something again here. Don't ever forget this. Yes, Ali, go ahead.
Is there a possibility that if two routers who are located in different LANs have the same highest IPv4 address, so will they
No,
contradict
no,
their...
there's going to be IP conflict. You can't.
Okay.
Let me give you a scenario. If you try it, the routers will start complaining. You have a router here, you have another router here. This is a switch here. You remember when we did the first up redundancy? You put an IP address here. You put an IP address here. If you put the same IP address, the IP address that is here, put on this interface here, they will tell you there is a conflict, that somebody is already using this IP address. It will complain because they are both connected to the same LAN. So that cannot work.
But if they are on two different LANs?
If they're on two different LANs, of course, they cannot have the same IP address because two different LANs simply mean two different networks.
Yes.
If they are connected to the same router, let's say you have a router like this, you have a LAN here, and you have another LAN here. This is a different segment. It will have its own network address. This is a different segment, its own network address. But if it is a LAN, standalone LAN, somewhere not connected, of course, you can repeat the IP addresses. Maybe this belongs to a different organization, and this belongs to a different organization. So you can repeat the IP addresses, but not on the same, within the same environment.
Okay. Thank you.
Any other question? Now, let me tell you this. In fact, let me launch one of the labs and see and show you. I have been in class with students and I will do something like this and I ask them, what type of routing protocol do you think is the best to use in this scenario? Some of them will say static route, some of them will say dynamic route, some of them will say OSPF or RIP or ERGRP. And if I ask you guys the same question, you're going to answer me probably the same thing. But that will be a wrong answer. Anytime you have just one router, you do not need a routing protocol because that router is directly connected to all the LANs. But the moment you have two or more routers, that is when you need a routing protocol. What is the definition of routing protocols? Communication language between two or more routers to exchange information about remote networks. Don't ever forget that. Communication language between two or more routers. You want to do static route, you are talking of two or more routers. You want to do OSPF, you are talking of two or more routers. But once you have just one router, there is no need for any routing protocol because the router is directly connected. You can link, you can see all those LANs. So with what we have on the screen right now, we can't demonstrate OSPF. So what do? I'll bring in another router. Or let me say I'll create another LAN and build another LAN. Imaginary LAN somewhere. And if I like, but I don't want to confuse you guys, I could have used the loopback interface, but let's build our LAN. We've been building LAN all this while. I should have used the one we use for static route, but I don't know where that one is. Let me just build this now. Let me check something. That one, we configured this. We configured this, but I'm not sure I saved it. Static route. I did not save that static route. So we configure, I'm setting up a LAN. Then I will link these two routers together. But let me build this LAN separately first. So let's assume this is our LAN. Let's pick an IP address for that LAN. Or network address rather. 192.168.102.0/24. You guys know this now. That's the same way we build the LAN that is in this place. So that's the same way we build two LANs here. We gave this one 192.168.100.0, 192.168.11.0. So these people can talk to themselves using a router. Let's say this is just, these locations are in, these two LANs are in London. And why do you have two LANs? Because you want to segment the network. Then let's have another LAN in New York. But it belongs to the same organization. So in the long run, we are going to link these two routers together. And there are different ways to get this things done. I took care of that in my one technology video on IPsec VPN. We can use VPN as long as this London router is connected to the internet and New York's router is connected to the internet. We can create VPN between the two routers and they will be directly connected. So let's build this network first, independent of the other side. So what do we need to do? We've decided on the network address. We just go to our router and pick an IP address and put on that router. Let's host name. Let's say New York. New York. Interface G0/0 IP first. So I'm done configuring that. So I'll go to the computers there, give them IP addresses based on that network. I believe we should all know this because I have built LAN tires in this class. And that's why I'm not slowing down to explain. So now we built this LAN separately. So let's see if this computer can talk to their default gateway. Their default gateway is 192.168.102.1. If they can talk to the gateway, then we are good to go. That means whatever the gateway takes them to, they can go. So let's check the other side. This guy too can talk to gateway. Whatever the gateway takes, this guy go. So this guy can go. Now, what do I want to do right now? I want to connect this router in London. Let me type London up here. This is New York. I want to connect the router, the LANs. Let me put it this way. I want to link the LANs in London to the LAN in New York. How do we do that? The two routers that are linking those LANs that those LANs are connected to must be directly connected. So what do? I link the two routers together, click my crossover cable. I've explained this to you guys again. I can click the router, go to any of the LAN interface G0/1, go to the other side. I think this name is affecting me. Let me move it. Now, another question for you guys. If you take a look at this topology right now, and I ask you the question, let me ask, how many networks do I have in this topology? I have done that analysis for you guys to understand here. Type the answer. How many networks do I have in this topology? I've analyzed it for you guys in under static routes. I didn't say how many lands. I did not say how many lands. Who is talking there now? Ali, can you help me? Who is the person talking there? Mr. Bulama, can you please mute?
Yep.
Okay. Please mute your mic. Okay, so some people are saying 1, some are saying 3. Akeredolu said 1. I say, how many networks do we have? I know it's one company, one organization, but they have multiple networks. Okay, some said 3, some said 4. So let's do the analysis. First and foremost, how many local area networks do we have? That is where you should start from. This is the first LAN. This is the second LAN. This is the third LAN. And I have told you guys, in between 2 routers is a network. And that makes us 4 networks. So we have 4 networks in this topology. Count your LANs first. If I had another router here right now, that becomes 5 networks. If I have a LAN here now, that becomes 6. If I have another LAN here, it becomes 7. If I had another router here on that side and had the LAN, that becomes 9 networks. Count the LANs first. In between 2 routers is a network. Don't ever forget that. So we're going to speak an IP address for this link, maybe 192.168.103.0/ maybe 30. You know, slash 30. You have to go back to your subnetting. Give this interface an IP address from that network. Give this interface an IP address from that network. These 2 interfaces belong to a network. Don't ever forget that. Is that clear? Ali, I see that you miss it too. Good. And others, please. I hope that is clear. Anytime you see a topology, you must be able to analyze the topology. Mr. Patrick, is that clear to you? Okay, good. Mr. Akeredolu, you missed it too. And Yola got it. So please, you need to understand it, because if you don't understand it, then you're going to run into trouble when you are doing configuration. So now I have done the LAN for that New York LAN. I need to configure the 2 interfaces between this London router and New York router. That means there's also going to be an IP address or a network address for them. So this time around, I have decided to use 192.168.100, sorry, .103.0/24. Or I can pick the /30 because it's a 1 link. Now, if you go back to your subnetting, you're going to see that anytime you have /30, there are only 2 usables IP addresses. 2 usables. Network address, broadcast address, then the first and second IP address. So I'll go to the interface of my router here, G0/2, put an IP address from that network. IP address 192.168.102. I can say .1. Watch out. Subnet mask 255.255.255.252. Back to subnetting. No shots. I'll go to the other side and do the same thing. Put a different IP address. Interface G0/2. IP address 192.168.103.2. I hope I put 103 on that side. No shot. So now let's think the other side. The other side is .1, 103.1. So let's see if we can ping. Don't forget what I told you. You build, you verify. You build, you verify. I think I made a mistake on that side. Let me go back there. What did I put there? Oh, I put 102. Did you see that? Did you see what I put? Instead of 103. So I can edit it. It's going to overwrite the other one. 103.1. That's why it's good to always build and verify, because if you have made a mistake, you can quickly detect the mistake. You see that it wasn't pinging. All our ping were lost. Now you see that we can ping. For those that don't know, the sign of successful connectivity on a router is exclamation mark. That's what you see there. Now, look at where we are. Look at where we are. London router is directly connected to this network. It can reach everybody here. It can help people here to talk to people here. It's also directly connected to this network. But London router does not know about this LAN. When we did static route, we were the one informing London router about this network address and the subnet mask and say forward it to this router. That's what we did. OSPF is different, or dynamic routing protocol is different. New York router is directly connected to this LAN, is directly connected to this network, but New York does not know about this LAN, does not know about this LAN. When we did static route, we were the one that would have gone to New York and tell New York about this network address with subnet mask and say you can reach it through this router. Tell New York again about the next network, the subnet mask, and say you can reach it through this node. But guess what? Dynamic routing protocol is different. So what do we do in dynamic routing protocol? OSPF precisely. We go to the router. Watch out. So we're going to go to the router. Under OSPF, we'll advertise this network. Advertise this network. Advertise this network. What do I mean by advertise? I will tell this router, there is somebody that is your neighbor. The neighbor needs to know about these networks that are directly connected to you. Use OSPF to discuss with your neighbor, because routing protocol is like a love language between routers to exchange information about the remote networks. We'll go to the other side also and say, okay, inside of your OSPF, you are directly connected to this network. Also directly connected to it. Tell your neighbor about the network. So we are leaving them to exchange information automatically. But we still have to get involved by advertising. Take note, directly connected networks under the OSPF, not remote networks. In static route, we configure remote network manually, but under dynamic routing protocol, we tell them to sort themselves out, even though we get involved briefly. Let's do it and see. I can go to my London router now. Let me show you all the route. Show IP routes connected. These are all the networks that are directly connected. The two LANs, one wide area network. So what do? I will go to OSPF and advertise all these networks. When we say advertise, we are going to tell London router, see, use OSPF, tell your neighbor about these networks. How do we do that? Go to global configuration mode. Watch out. We want to configure OSPF now. Router OSPF. In fact, before I get there, if I say router and I put question mark, I can configure BGP. I can configure EIGRP. I can configure OSPF. I can configure RIP. These are different dynamic routing protocols we discussed in our last class. But the one we want to configure now is OSPF, which is open shortest path first. So I'll say router OSPF. What is the next thing? Process ID. We've talked about process ID. Look at the range. I can decide to say router OSPF 100. And the number must not be the same on all the routers. You can use different numbers. It makes no difference. But best practice, you are supposed to use the same, you should try to use the same number. So the moment I say router OSPF 100, that 100 is the process ID that will identify the routing process on London router. And I hit enter right now. Look at my prompt. My prompt has changed to config router. This is what we call router configuration mode. Router configuration mode. So what do I want to do in this place? Oh my goodness, there's a lot we can do here. Plenty. Just one thing here. Let me show you the commands. If I put question mark now, look at all the things we can do. So many things. And we're going to take care of most of them. Not all, most. But what we want to do right now, this is the command we need. Network command. What do we want to do with the network command? We want to use it to advertise the directly connected network. So back to that my command, do show IP route connected. I've told you why I use do. Anytime you are not at privilege mode and you want to use show command, you add do to it. So I'll say do show IP route, and then what will happen? I'll hit enter. Why did I do that? Ali, can you still hear me? What about now?
We can hear you now.
Okay. I just saw the sign that my network is fluctuating. All right. So the command is network command. Then you put the network, then the subnet mask. Yeah, thank you. Now look at what I'm doing here. I want to advertise all these three networks. These are the networks that are directly connected to London router. So I will say network 192.168.100.0. Then I will put the subnet mask. And guess what? I will put that interface or that network in area 0. We have discussed this before. The only area we're going to be dealing with in this class is area 0. And I will hit enter. What did I do? I have simply told London router, when you do form neighbor with New York router, when you become friends with New York router, in the process of discussing, tell New York router about this network that is under you with his subnet mask. Then I will go to the second one. Same thing. 192.168.101.0.255.255.255.0 area 0. I will hit enter. Becoming to network now. Then I will go to the last one and say, okay, this is the third network that is directly connected to you, which is 103.0, and the subnet mask is okay, 252. So look at this now. These two here are our LANs that are directly connected to London router. This network here is the one for the WAN connection, wide area network connection. We are going to advertise all these three networks on London router. So what have we done? We have configured OSPF. And we are done on London router. But guess what? Nothing is going to happen now because we have to go to New York router to do the same thing. So when I go to New York router, what will I do? Same thing that we did here. Show IP route connected. For me to see the networks that are directly connected. This is my LAN on New York router. This is a wide area network link on New York router. I will do similar stuff. Go to global configuration mode. Router OSPF 100 network. All the networks that are directly connected on New York router. Before I finish it, let me show you something. Let's talk about it now. If I issue the command show IP route, look at our routing table now. we can see the directly connected, and the local host. That is the one that the directly connected IP address. If you take a look at all these networks here, you are not going to see remote network here, which is our 102. 102 is not here. What we did when we did static route, we will have informed London router about that 102. But by the time we are done with this OSPF, you are going to see what will happen. Going to the other side also, let's check the routing table of that guy there. Let me get it up. Do show IP route. Look at the routing table. This guy only has 102 and 103. It doesn't have 100.0. It doesn't have 101.0. So that means it cannot reach those networks. It can't help anybody under it to reach those networks. But the moment we are done doing this configuration, you will see what will happen. So do show IP route connected so that we can see the connected network. So I want to advertise network 192.102.0.255.255.255.0, then area 0. Then with network again, network 192.168.103.0. That is our one link /30, which is 255.255.255.252. Then area 0. Watch out what's going to happen now. Because I am doing this on the one link now, this router will start from neighbor. Let me see if I can do debug IP OSPF. What did you see? Did you see something like loading to full, then done? And we discussed that in our last class where we talked about different stages of OSPF packets. When they talk to themselves, listening, learning, and all of those stuff. Now, what's happening here? What is happening here? Have these guys formed neighbor? Let's find out. On London router, do you have, oh, look at it here too. It's loading to full and then done. Anytime you are doing OSPF, once you see this loading to full, know that you have done the right thing. But if you don't see it, something is missing somewhere. That means the routers have not formed neighbor. But the fact that these routers are formed neighbor doesn't mean that they are going to share the information. If you do not advertise the information, they can't share the information. So let's find out if they are formed neighbor. First command, show IP OSPF neighbor. Show IP OSPF neighbor. So look at our neighbor here. 192.168.103.2 is our neighbor. The priority is 1. The state we have with that neighbor is full, and the neighbor is BDR. Come. Why do we have election here? I have told you in the last class. When you are using Ethernet, OSPF will form neighbor. I mean, they will do election and select who becomes DR and BDR when you have Ethernet. But we don't want it to be like this. We are going to change it later when we leave this area now. Okay. That's first command, show IP OSPF neighbor. Next command, show IP OSPF interface. Do you want to see the interfaces that are running OSPF? I think they should be brief. Yeah, brief. You want to see the interfaces that are running OSPF. You can see my G00 is running OSPF on this router. G0/1 is running OSPF. G0/2 is running OSPF. How come they are showing that they are running OSPF? Because the networks on those interfaces, I advertise them inside OSPF in area 0. So sometimes when you don't see a particular network, just find out what's the port ID of that network. Is that ID running OSPF? That port ID is running OSPF. Show IP OSPF interface brief. All the routers, all the ports on this router that have connection must show themselves. Okay, that's not all. Show IP OSPF. Which one is there again? I've showed you neighbor. I've showed you interface. I don't want to go into database now. It's going to create trouble for me. Maybe later. I think there should be one more. We'll see in the PowerPoint. But that's not where I'm going to now. London router. You are form neighbor with New York router. Can we find out the information you got? Show IP route. If you hit enter, you can see that London router got information. How did he get this information? He got information about 192.168.102.0. Through what? O. What's the meaning of O? Look at O here. O means through OSPF. This network you are looking at here is not directly connected to London router. But now London router has that network in its routing table. So how did this network find its way into the routing table? Because this network has been advertised under OSPF in New York. Let's go to New York and find out what New York got. We go to New York router and see what it has gotten. Let's just see show IP route. We want to see only OSPF routes and hit enter. New York has learned about 192.168.100.0. New York has learned about 192.168.101.0. How did New York get to know about these networks? These are local area networks under London. They are not directly connected. Look at it here. He got to know it through OSPF. Look at it here. He got to know it through OSPF. What about this number in between here? That is the administrative distance. We'll talk about administrative distance in this class. What about this one here? That is a metric. Via who? Where? How can I get there? This is the person that can help me to get there. So what has happened? The two routers have exchanged information about remote networks automatically. So what is the advantage of this? If I go to London now and shut down this interface that connects to 101.0, New York router will automatically remove it from its routing table. Why? Because it keeps on communicating with London router. If London router no longer send that information that that network is still alive, it will remove it. Then that is the advantage of dynamic. If it is static, we have to remove it manually. But if it is dynamic, when the network goes down, it is removed from the routing table. And I will show you later. Let me be sure we're okay with this explanation. Are we good with this? Talk to me. You see, I've spent almost 1 hour already. And that's why I say I don't think I can finish this slide. Good, 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 good. Thank you, Mr. Peter. So this one is dynamic and we are using OSPF. You just advertise the directly connected networks on each of the routers and they will sort themselves out. If a network goes down, they will sort themselves out. When the network comes back, they will sort themselves out. Thank you. There's something we've not discovered here, or we've not put our attention. This London router, can we check your ID? We talk about router ID. Show ID. Show IP OSPF interface. I don't want to put brief. Let's go somewhere and see. The ID on this router, look at the ID of this router. This, my London router, decided to pick 192.168.103.1. Why? There are 3 IP addresses on this router. One is 192.168.100.1. The other one is 101.1. The other one is 103.1. And we have said the router will pick the highest IP address on the interface, any of the interfaces as its router ID. But we may not like this. We can overwrite it. But before we overwrite it, let me do something. Let me go and create loopback interface. Loopback configuration interface, loopback, let's say 1. Just put any IP address, say 200.100.100.100, 255.255.255.255. That is, we call it a network of one host. I'm just concerned about this IP address. I don't bloody care about the network address or broadcast address. I am just concerned about this IP address. If I reload this router now, let me reload this router now. You see what is going to happen. The member will say from the order, router ID order, if there is a loopback interface, even if it has a lower IP address, I should have used a lower IP address. The router will pick the loopback interface address as its router ID. Show IP OSPF interface. I should have used a lower one, but you got the idea. What did you see here? The router ID is 200.100.100.100, not because it is higher than the other one, but because it is a loopback interface address. Let me change it. Which loopback did I even go to? Let me check. Loopback 1, okay? Let me change it. Interface loopback 1. No IP. So let's now pick a lower IP address, say 150.100.100.100. 150 is lower than the others. Save and reload this router. So loopback address take precedence if you have it. But if you don't have loopback address, then the highest IP address on the interface takes precedence. But what if you have more than one loopback address, maybe like 2 or 3? The highest loopback IP address takes precedence. So for router ID. Oh, show IP OSPF interface. So let's find out. What did we see here? This is not the highest IP address, but because it is on a loopback interface, the router will use it as its router ID. It would not have, if you don't have any business with the physical interfaces addresses, it will only pick the logical interface, loopback interface address. But most of the time, this is not what we want. We want to override this thing. So how do we override this? We do this, router OSPF 100. Were we using 100? Yes, process ID 100. I want to override that. So I'll say router ID. Router ID. I can just pick 1.1.1.1. Hit enter. It will tell me that this thing will only take effect if I reload the router or I use clear OSPF process. Okay. I want to use clear OSPF process. Clear IP OSPF process. What will that command do for you? It will restart the OSPF neighborship formation. Everything will start all over again. But I don't want to do it now. Let me go to the other router. Okay, I say New York router. What's your own router ID? Show IP OSPF interface. Your router ID is 192.168.103.2. We don't want that. We go to router OSPF 100, router ID 2.2.2.2. I hit enter here. It will tell me to reset. I can just reset on one side, it will work. Instead of doing that, reset on both sides. So if I reset this right now, reset all those OSPF, I say yes. So now you see that command again, show IP OSPF interface. What did you see here? The router ID is 1.1.1.1. This command take precedence over loopback and over what do you call it? The physical interfaces IP addresses. Show IP OSPF interface. Oh, I need to use this command here or reload. Sorry. One side will not take care of it for me. Clear IP OSPF process. So what I will always, I'm supposed to be at privilege mode, so I can add do to work. So what I always advise people is at the initial stage, once you start configuring your OSPF, decide on your router ID and put it straight. So once you say router OSPF 100, router ID, put it straight before you even advertise the network. You need to be aware of this. So let's find out. You can see now that this router has picked the ID of 2.2.2.2. How did we do that? We use router ID to override that. Hello?
We can
Ali,
hear
can
you
you hear
now.
me? All right, sorry, it's the network that is messing up. All right, okay. So, Beth, did you get my explanation before we lost the audio?
No, sir.
Where did you stop hearing me? Ali, can you talk to me? Where did you stop hearing me? You saw how I changed the router ID now.
Yes, sir, we saw that.
And that's what I said last. I just displayed to you people that the ID has changed. Router ID command. So I was just trying to say, whenever you want to do OSPF configuration, or when you go to global configuration mode and you say router OSPF, say 100, the moment you hit enter, the first thing you should do is do your router ID. Put whatever you want before you advertise the network. That is the point I'm making. Is that clear? The reason why I didn't do it immediately is to show you guys what the router will do without the router ID command. It will pick any of the IS IP address on the interface. The IS IP address on any of the interfaces will be selected as the router ID. But that is not what we want. We want to be in charge. That is why we use router ID straight away. All right. Any question on that before we proceed? Thank you. So you see, I put an IP address on the interface, the loopback interface, and then you saw what happened to the router. What the loopback interface simply does is just to simulate a network of one host, and we don't need to activate OSPF on that interface. It just simulates a network of one host. Okay, so look at what they did on their home. Router ID 1.1.1 on router 1. And what did they do? So when you put it, you clear the IP OSPF process, and then you can see the router ID. I think I like this, their command. Show IP protocol. Yeah, that's another command I think I missed out. How on earth did I mean that now? So how do you know the protocol we are running? I should have started from there. Show IP protocol. We are running, the routing protocol we are running is OSPF. and the process ID is 100. The router ID on this router is 2.2.2. The networks that we have advertised, look at them here. This command is very, very important. Very, very important. These are the networks we have advertised. So now if you come down, you're going to see it's showing us the information source. It's telling us gateway 1.1.1. What does that mean? I'll talk to it in another class, maybe next class. That's the next router, my neighbor. This is my own. I'm also a gateway. Then I can advertise this loopback address. And then this is another gateway, physical IP address. This is another gateway, physical IP address. I think this is the first one I put. It did not remove it. It's supposed to remove it. I don't know why. Let me check. Show run. So that's it's no longer in my running config. Okay, maybe because I have not restarted this router. That's why it's still in the run. So that command is very important. We need to be aware of this command also. Show IP protocol. It's going to show you the routing protocol you are running. And you can pipe it and include router ID. And that's that on this particular section. So can we proceed? Are we good? Okay, thank you. So the next thing to talk about here is point-to-point OSPF networks. I've talked about this in the last class, and I'm going to repeat that again. Let me show you something here. I like this. Let me show you. Let me explain something to you. Back in those days, when you link two routers together, we always use what we call serial connection, serial ports. By default, when you run OSPF on this router, OSPF will see this network as point-to-point. What is point-to-point? It is only expecting to have one neighbor on the other side. So London router and New York router. The London router is seeing that I only have one neighbor. And New York router is saying that I only have one neighbor, or I'm expecting only one neighbor. That is point-to-point. But the moment you link the routers together and you are using Ethernet ports, when I say Ethernet, it could be fast Ethernet with gigabit, and you run OSPF on this router, OSPF sees this network as broadcast multi-access. And I've explained this in the last class. Multi-access is you can add, if you drop a switch here now, you can add another router. 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 It is broadcast. I mean, it is multi-access. But why is it called broadcast? If there's a broadcast from any of the router, it goes to everybody. So what we have right now, we are those two routers. OSPF is seeing it as multicast, broadcast multi-access, but we don't want OSPF to see it that way. So we want to override that feature inside OSPF. We want to let OSPF know that even though you don't see this guy as point-to-point, but we are telling you that this is point-to-point. Only one neighbor is expected on the other side. But before we do that, let us see the way OSPF is seeing our network that we configured now. Because we are using Ethernet ports, Ethernet connection. Let's see the way it's seeing it now. So I'll go to London router and put show IP OSPF interface. I am going to, which interface is that? The one the routers are using to connect to themselves, G0/2. So I should be able to go directly to that G0/2. Let me see. Okay, good. Show IP OSPF interface gigabit 0/2. What do you see in this place? Network type, broadcast. That's the way this router is seeing this interface. But on that interface, we have only one neighbor on the other side. And so we want to tell this router inside the OSPF, this interface is not for multiple connections. or multiple routers. This interface is just meant for one other router on the other side. So how do we do that? We'll go to that interface. And we'll say IP OSPF. I think it's network, yes. Look at what we have. Point to point. IP OSPF network, point to point. Meaning we don't want it to be broadcast. We want it to be point to point. I'll go to the other interface. Now take note, this is done between the interfaces that connect the two routers together, not on the LAN. I'll do the same thing. IP OSPF network, point to point. If I go back to this router now, you will see what will happen here. Look at network type now. Network type is now point to point. So what is the advantage of this? There will be no election. On a broadcast multi-access network, there is DHL and there is BDR. But when we have a point to point, there is no election. So if I now go back and say show IP OSPF neighbor, did you see DR and BDR there? Before we saw DR and BDR, but this time around, we just saw that they form neighbor. And it's because there is no election. So the neighbors, the type of neighborship they form is full. And look at it here now. Our neighbor ID is 2.2.2.2. Priority is 0 because we don't need it. There's no need for any election. It's when you have election, you talk about priority. There's no need for election now. So that's why you do point to point. Let's go through this slide. One command, and that's done. Story. Let me see the configuration. No configuration here. Okay. You can specify the interfaces that belong to a point-to-point network by configuring the network command. You can also configure OSPF directly on the interface with the IP OSPF command. Of course, you can do that. Maybe I'll show you guys later. Instead of advertising the network, I can just go to any of the interfaces and put OSPF. In fact, let me show you. Remember, we have a loopback interface on this router. Show IP interface brief. Is this? Oh, okay, I think it's on London. Sorry. The loopback interface is on London. That interface, we did not advertise it in OSPF. That IP address. Show IP interface brief. Look at this loopback here. What if I want this address, this loopback interface address, to be sent to New York? I have to advertise it under my OSPF. But instead of going to router OSPF and then say network, I can just go to that interface straight now. Interface loopback 1. And then say IP OSPF 100 area 0. Whenever you put an interface in area 0, the IP address on that interface is advertised automatically. I repeat, whenever you put an IP address inside OSPF, or an interface in OSPF, and you define the area as area 0, any IP address on that interface is automatically advertised. So if you like, now when you are doing my lab, instead of you going through the first route, you can just go to all the interfaces and say IP OSPF 100. The 100 there is the process ID, and then put that interface in area 0. Any IP address on that interface is advertised. So that is another way of advertising the OSPF in area 0. Okay. I'm trying not to leave anything behind. Although the area, when configuring a single OSPF version 2, the network command must be configured with the same area ID. Yeah. So if you have a router here, if you have a router here, whatever you configure here, the area must also be configured here. If this one side is area 1 and the other side is area 0, they cannot communicate. They won't form neighbor. They must be in the same area. Okay, that one is not a problem. But I need to show you guys something here. And I did this deliberately. When we advertise the network, I put 192.168.100.0, then 255.255.255.0, which is the subnet mask. But the OSPF do not like this, or they do not really use this. They use what we call wildcard mask. What is a wildcard mask? Wildcard mask is the inverse of subnet mask. Wildcard mask is the inverse of subnet mask. Take for instance now, if you wrote 255.255.255.0, and I ask you, this one is a subnet mask now. I ask you to give me the wildcard mask of this subnet mask now. You just invert it. And the easiest way is just remove it from 4.255. This one will give me 0, 0, 0, and then 255. This is what is called a wildcard mask. Wildcard mask is simply the inverse of subnet mask. Let me show you something. In our router, if I go to my routing running configuration file right now, you will see the way the OSPF is displayed. The OSPF we configured. The networks we advertise rather. Where are they? Yeah, like this. Look at what you say here. Is this what we advertise? And I did this deliberately to let you know that if you like, you can just use the subnet mask. The router will convert it. It will invert it for you. This was not like that, but it wasn't like this back in those days. You have to know this conversion yourself. When you are configuring OSPF, OSPF does not use subnet mask. It uses wildcard mask. Wildcard mask is the inverse of subnet mask. But if you don't want to stress yourself, just put the subnet mask. Your router will do the conversion for you. But you also need to know how the router did the conversion. So wildcard mask is the inverse of subnet mask. Look at the one for /30, 255.255.255.252, 255.255.252. What will be the invert? If you invert it, what will be the wildcard mask? This one with 0, this one with 0, this one with 0. This one just removing from 255. This one is going to give you 3. This is called wildcard mask. OSPF uses wildcard mask. They don't really use subnet mask. And if you don't want to stress yourself, just put the subnet mask. It will do the conversion for you by itself. I don't know if this is clear. Please let's talk to me. You know, this advantage of online training. I don't see your faces. Okay, good. Even though I want to see your face, I cannot monitor everybody simultaneously. Now, when we come to access list, that will be next week. We're going to use wildcard mask again on that access list. So in OSPF, they do not really use. Eniola, are you cool? Are we all good? Okay, yes. Good. Okay, so we don't have much to talk about there. So we need to run now. So don't bother using, except it is explicitly specified that you should use what do you call it? The wildcard mask. Then you can decide to use the wildcard mask. That is one. Then let me be sure that that is all here. Okay. That's that about wildcard mask. Another way to configure OSPF, I can specify the network address on that interface. I can specify the IP address on the interface. Like in this scenario right now, they advertise the network, and put the wildcard mask. But if you look at another configuration, they advertise the IP address on the interface of one of the interfaces, 1.1, 10.10.1.1. That also works. By the time you advertise the IP address on the interface, it's going to factor in all the network address on the interface. That's in the main network address. That also works. But anytime you are using the IP address on the interface, your wildcard mask is going to be 4 zeros. If you are using wildcard mask. And if you want to use subnet mask, you are going to use 4255s. If you are using the IP address on the interface. But my preference configuring OSPF is to go to the interface and just say IP OSPF, maybe 100, then area 0. Do it on all the interfaces and I'm good to go. So you can decide to use any. The labs I'm going to send to you, I don't know what is in the lab, but you follow the instruction that is in the lab. Okay? And how do you remove what you have put? Anytime you want to negate, you say no. Then follow with the command you have put. You can decide to yank off everything. Look at what they did in this place right now. They enter into this interface. They say IP OSPF 10, area 0. Enter into another interface, IP OSPF 10, area 0. Enter into the loopback, IP OSPF 10, area 0. It will achieve the same result as this. That is done on that one. Any question before I go to the next one? Let me see where I want to stop today. I told you we can't finish this today. The next class, definitely we're going to finish. It may probably be a short class. I don't want to, well, I don't want to leave anything behind. Okay? Are we good? Can we continue? Few more slides, will be done. All right. Another concept under OSPF we talk about is passive interface. Yes, you can use subnet mask. You can see that that's what I used first before I went to show you guys the wildcard mask. Is that clear, Mr. Samuel? One more thing and we'll be done today. One more thing. So you don't get overloaded. Okay, you need to understand something. I know you read ahead. I know very well you read ahead. But you saw that what we did now works. Just that we didn't test for connectivity. But you know that is going to, it's from my CCI knowledge. When I went to India, I learned that from India. So, but if you doubt me, just use the wildcard mask. But you saw that we used the wildcard mask and the router did the conversion for us. But that was not possible back in with some routers. But they've made the operating system smarter in such a way that you can decide, or let me say, you can do that conversion for you. All right, so this should be the last thing I'll talk about today. Passive interface. By default, OSPF messages are forwarded out or OSPF enable interfaces. However, this message only needs to be sent out interfaces that are connected to OSPF router. What are we talking about now? Look at something here. Look at this, our topology. These two routers are sending OSPF messages between themselves, but they are also vomiting OSPF messages on their LAN. So if you have a bad guy here, threat actor, he can decide to capture OSPF messages from this router. If you have a bad guy here, he can decide to capture messages coming. If you have a bad actor here, you can decide to capture messages. As a matter of fact, you can decide to launch your own router and connect to this other router and form neighbor with that router and begin to harvest information about the network. So it's a security problem. So what do we want to do? We want to tell our router, don't send OSPF messages out of this because there's no neighbor here. Don't send out on your LAN. Don't send out on your LAN. That is what passive interface is all about. We want to say only send between on the interfaces where you have neighbors. You can advertise the network on those interfaces, but do not send messages out as if you want to talk to another neighbor somewhere. That is the essence of passive interface. So sending out unneeded messages on the LAN affects the network in three ways. Number one, we're wasting bandwidth. Inefficient use of bandwidth. Available bandwidth is consumed transporting unnecessary messages. Number two, inefficient use of resources. All devices on the LAN must process and eventually discuss the message because it's not meant for them. They will receive it, they will check it out. They were using their CPU, they are using their RAM. That's not good. Number three, which is the most dangerous, increased security risk. Without additional OSPF security configuration, OSPF messages can be intercepted with packet sniffing software like Wiresharks. Routing updates can be modified and sent back to the router, corrupting the routing table with false metrics that misdirect the traffic. For this majorly, you make sure you make all the LAN interfaces passive. How do you do that? I'll show you. So you go to the router OSPF environment and say passive interface loopback 0. Like in this scenario right now, we have our LANs on G0/0 and G0/1. So I'll go to my router and say and go to my router, go to global configuration mode, router OSPF 100, don't forget, passive interface, gigabit 0/0, that's 1. Then the second one, gigabit 0/1. Those are my interfaces. What I'm simply telling this router is do not send update out of these two interfaces. Then I'll go to the New York router and also do the same thing for my LAN connection or my LAN port. The router OSPF 100 passive interface gigabit 0/0. You see, do not send update out of these interfaces. That is how you activate this. This is very important when you are configuring OSPF. The networks there will be advertised, but updates will not be coming out. And if we issue show IP protocol command, it's going to show you the interfaces that are passive, like in our situation right now. If I go to my router here right now and say show IP protocol, you'll see that this is the only interface that is passive on New York. If I go to London router, and say show IP protocol, you see the interfaces that we have declared passive. They will just be sitting down there. What happened actually is the updates are suppressed on those interfaces. They are suppressed, so they won't go out. It's like you block the door. So once the router sees those updates coming, just block them on those interfaces. So you need to do this whenever you are doing OSPF. I've done this IP OSPF, and we've seen we turn from broadcast to point. We're taking care of this. We can also change our loopback interface. Why do we need to change loopback interface into point-to-point? By default, loopback interfaces, we advertise, OSPF will advertise loopback interface as broadcast multi-access. So we'll always need this command to take care of that. And I think that's where I would like to stop today. Multi-access, I've also talked about it last week, but maybe we'll just do revision next class and then continue to the last part of the class. Any question on this? So we learn the configuration of OSPF basic. We learn how to change router ID. Then we learn how to configure passive interface. If I go back to that environment, I told you we've used this command. No, we've used this command. We've used this command. We have used this command, making 3. In our next class, we're going to use this command. And we can also use this one also. We'll check it out. So almost all the commands from the from the under router OSPF, we're going to make use of almost all of them. Almost all of them. Some practically, some I'll just explain them. And that is that on this part. Any question, guys? Okay, are we good? All right. So when we
Sorry,
come
sir.
to now, yeah, please go ahead.
Okay, sir. In the when configuring two routers together,